Okay, let's solve sine 2x minus sine x equals 0 for all x values in radians. Okay, well, the first thing I notice is I have a double angle here and just a single angle here. So we want to get everything in terms of a single angle, a single x value. And we can use the double angle formula or double angle identity for sine to do that. So the sine of 2x is equal to 2 sine x cosine x. Then we still have minus sine x equals 0. I'm going to solve this equation by factoring. Factor off the common term, which is sine x. And what's left is 2 cosine x from the first term minus just 1 from the second term. And then the equation is still equal to 0. Okay, at this point set both factors equal to 0. Sine x equals 0 or 2 cosine x minus 1 equals 0. Okay, if you solve the sine of x equals 0 for values between 0 and 2 pi, you'll get x equals 0, but also x equals pi. And the directions in this problem actually say solve for all values of x, not just between 0 and 2 pi. But if you think about it, the sine function, here's a pretty bad picture, that's supposed to be the x-axis right there. The sine function looks something like this. Here's 2 pi, pi. It also keeps going in the left-hand direction, it keeps going in the right-hand direction. And if you think about it, at multiples of pi, including 0, negative pi over here, 3 pi will be over here, and so on and so forth, at all multiples of pi, you're going to get the sine of that value, the sine of pi, a multiple of pi equaling 0. So you could say that all the solutions everywhere for that first equation would be x equals some integer k times pi. So there's all the solutions for that first equation. Now what about the second equation? Let's go back up here. For the second equation, let's solve this for cosine x. So add 1, divide by 2. The cosine of x is equal to a half. Okay, well, in the first quadrant, x would have to be pi thirds. But there's another quadrant in which the cosine is positive. It's the fourth quadrant. So treat the pi thirds like a reference angle. And the angle in the fourth quadrant, whose reference angle is pi thirds, will also produce 1/2 when you take the cosine of it. And okay, so how do you get that? Well, just take 2 pi minus pi thirds. And 2 pi is 6 pi thirds. So 2 pi minus pi thirds is just going to be 5 pi thirds. So, okay, in between 0 and 2 pi, for that second equation, we get we get pi thirds and 5 pi thirds. So how do you generalize those solutions? Well, I'm not going to get too creative here. I'm just going to say, for that second set, you could say x equals pi thirds. Okay, plus if you add the period, if you think about it, the period of the cosine function, up here the period is 2 pi. So if you just add multiples of 2 pi, you'll have other solutions. So pi thirds plus 2k pi, also 5 pi thirds plus 2k pi represent all the solutions to the second equation, where k again is an integer. So just to summarize, we have x could equal pi times k, pi thirds plus 2k pi, also 5 pi thirds plus 2k pi, where k is an integer.